Hello guys, I'm Aluko Enoch. Welcome to my math tutorial class on transformation. For today's session, I'll be working on the IGCSE exam style questions. Now we are going to take a look at the four major subtopics in transformation: translation, reflection, enlargement, and rotation. So for this first section, I will take a look at translation and reflection. So let's take a look at the question. On the grid, draw the image of triangle T after translation vector minus 4 4. Okay guys, there's something you need to know about translation vector. Generally translation vector is of this form. So you have the x and the y coordinates. If the x coordinate is positive, then that implies that you move to the right hand side. If the x coordinate is negative, you move to the left hand side. If the y coordinate is positive, you move up, and if the y coordinate is negative, you move down. So by implication, minus 4 4 implies that our first step to the left and first step up. So before you attempt any question or start solving any question in transformation at all, the first thing is for you to label your object, that is identify the coordinates. So the coordinates now, this one, let's just take this one as the A, the point, then this is B, and this is C, because you need to know the coordinates of the point. So it's it's more of a point translation. So let's go ahead and translate the first point A. So I'm going to apply this translation vector to it, minus 4 4. So mean that from point A, I will take first step down, first step up. So from point A, first step to the left, 1 2 3 4, then first step up, 1 2 3 4. So I have a new coordinate, and that I'm going to tag that A prime. Okay, so A gives A prime based on this translation vector. Then let's do the same, apply the same translation vector to point B, 1 2 3 4, then first step up, 1 2 3 4. So I have my new point B here, so I'm going to tag that B prime. Then I assign the same translation vector to point C, first step to the left, then first step up, 1 2 3 4, 1 2 3 4. So and this is the result we have here. So then the final so finally just join each coordinate with a straight line. Okay, so that's it. So join A to A prime, B to B prime, and C to sorry, A prime to B prime, B prime to C prime, then A prime to C prime. So that gives all that gives all the image. So let me tag that, and since I'm through with question 1, let me just tag it I1. So I1 is the image for translation. So and the next question is reflection question. So triangle T after reflection in the line y equals to minus 1. So go to y-axis. This is minus 1 on y-axis. So draw a line across that. So draw a line across this. So this line is y equals to minus 1. So I can tag the line y equals to minus 1. And please, you need to remember in reflection, and each point you count the distance from each point must be the same with the distance from the object to the mirror line should be equal to the distance of the object to the from the mirror line to the image. So from point B now, how many steps are you going to take to get to the mirror line? So I'm going to you count 2 square boxes. So 1 2. So by implication you have to count 2 boxes away. So 1 2. So I'm going to get my new B. So that will be new prime, B prime. So and the same principle is applicable to this now. So A to the mirror line, 1 2, they count 2 steps away, 1 2. So this will be my new A. And finally the same rule to C, from coordinate C to the mirror line, 1 2 3 4. Then you count 4 square boxes away, 1 2 3 4. So this will be my C prime. Then you can now join the coordinates, now the new coordinates. So join A prime to B prime, B prime to C prime, C prime to A prime. So let's tag that I2. So that is image 2. So and image 2 is as a result of reflection, while image 1 is as a result of translation. So we are through with the first two subtopic in transformation. So let's go to the next two, that is enlargement and rotation. So I can clear my board now. So let me import enlargement question now. For enlargement question, we have a lot of questions here. Let's just go for E10. Okay, so this is a good one. So now the question says that enlarge the trapezium by scale factor 3, center 60. So we have a center of enlargement. Okay, so you are given center of enlargement. Okay, so and in enlargement, you need three information. You need the enlargement point, or better still, center of enlargement. You need the scale factor. So you need the enlargement point and the scale factor. Then scale factor is okay. My handwriting is not that bad, or can I just undo that? So SF is scale factor, don't forget. EP is enlargement point. Okay, so we have the enlargement point and the scale factor. Those are the two major information needed. Okay, so and then you have your object here. This is the given object. So let me just tag it O object. Okay, so the first thing is I need to get these coordinates, but the problem with this is scaled. Okay, I have 0. This point let's just label A, B, B, C, and this D. So we have 4 different coordinates for the trapezium. So the problem here is that A is not 4,1. A is not A can only be 4,1 if the enlargement point is center 0, 0. So from center 0, 0, yes, it will be correct to use 4,1, and B will be like 6,1, and C will be 6,2, and D will be 5,2. But it will be wrong based on this center of enlargement, because the center of enlargement is not 0, 0. So this scale will not work. So you have to go ahead and let's quickly just identify this 6, 0. So this means that X coordinate is 6 and Y coordinate is 0. So and this is on X axis, so this is 0.6, 0 here. So now this 6, 0 is the enlargement point, or center of enlargement. So now from the center of enlargement now, so from this point now, you can now go ahead and define. For example, if you want to get A, if it has to be 0, 0, so from 0 to A, that is 1, 2, 3, 4, 1. That is how this will be 4,1. So you always count from the center of enlargement. So conventionally, the coordinate system, anytime you are working in geometry, we always work with center 0, 0. But now transformation now gave us a better idea of how to a better understanding of how we actually come about 4,1 and this, because actually from the enlargement center of enlargement, or enlargement point, or whatever, it will also be center of rotation. So but that is just the reference point. So let me just call it the reference point. So the reference point here is 6, 0. So from the reference point to A to B to C to D, that's what we are going to do. So since we are dealing with enlargement, so I'll just work with this. So let me just write again. I need to be fast now. So I have 4 coordinates here. So let me have EP in 4 places. EP, then EP, then finally EP. Okay, so now because I want to use my arrow now. So now from the enlargement point to A, from the enlargement point to B, from the enlargement point to C, from the enlargement point to D. So that will give me the real coordinates, the conventional coordinates we can work with now. So now let me use software now. So from enlargement point to A. So what is enlargement point to A? So you count, it's like from this point to A. So you are moving from this point to A. So how is your movement going to be like? You have to move left or right before you can move up and down. You can't move like this. So you have to move left or right before you can move up or down. So now from 6 to A. So this is to the left hand side, because 6, 5, 4 is reducing. So 1, 2 steps to the left and 1 step up. So 2 steps to the left means -2. 1 step up means 1 for Y, because generally we have X, Y. Don't forget, it's always X, Y. Okay, so from enlargement point to A now, that is 2 steps to the left and 1 step up. That is -2, 1. So -2, comma 1. So that is the coordinate for A now, guys. So you see that the coordinate for A is not 4, 1. It is actually minus 1 based on the enlargement point, guys. Okay, then from enlargement point to B, enlargement point to B now, this is the enlargement point. So I'm moving from here and B. So B is directly overhead, is directly on it. So I'm not going to move either to the left or right. So since I'm not moving left or right, so that is 0. So S coordinate is 0. Then just move up. So that is 1 for Y. So 0, 1. From enlargement point to C, C is also directly overhead here. So you're not going to move either to the left or right. So it's directly, okay. So that's 1, 2. So that's 0, 2. Then finally, from enlargement point to D, and this is D here. So enlargement point to D. So you have to move either left or right before you can move up and down. So this is 1 step to the left, then 2 step up. So that is minus 1, 2. So guys, hope you understand how to determine your coordinates. If the enlargement, if the reference point is not 0, 0, because reference point can be any of these points here. Okay, so finally, to get my image now, in enlargement, you just use K factor to multiply the respective coordinates. So the K factor given is 3. So since K factor is 3 now, so I need to get A prime, then B prime, then C prime, then finally I should get D prime. Then I will join the 4 coordinates to get my image. So now, so what I just to do, just use 3 to multiply the respective coordinates. So 3 to multiply A coordinate A to get A prime, 3 to multiply B to get B prime, and so on like that. So now let's go ahead, please. So now if you look at this now, so 3 times minus 2, that is minus 6, and 3 times 1 is 3. So A prime is minus 6, 3. So the same thing for B prime. So B prime will be 0, 3. Then C prime will be 0, 6, because I use it to multiply 0, 2. Then D prime will be minus 3, 6, because I use 3 to multiply minus 1, 2. So that's minus 3, 6. So that's the coordinates. So guys, you cannot just go ahead and plot what am I doing? Yeah, no problem. So guys, you can't just go ahead and if you are even observant, you see that guys, there's no minus 6 here. What is this Aluko teaching us? He's teaching us rubbish because there's no minus 6. So don't forget that we have an enlargement point. So guys, so you also take it from the enlargement point. The enlargement point is this, and let me just write EP there, enlargement point. So from 6, 0. So the implication is this one is 6 steps to the left, because you know this is X and Y. If X is negative, you move to the left. If it's positive, to the right. So this one, interpretation of this one is 6 to the left and 30 up. This is one, no, we are not going to move left or right, just 30 up like that. Okay, so from enlargement point now, 6 steps to the left and 30 steps up from here. So 6 steps to the left, 1, 2, 3, 4, 5, 6. Then 3 steps up, 1, 2, 3. So this will be the new A. So that will be, this is my A prime now. So that's my A prime. So from enlargement point again, go ahead and do 0, 3. 0, 3 means that you are not going to move either to the left or right. You just 3 steps up. So 3 steps up now. 1, 2, 3. So this will be my B prime. So go ahead and for C prime. C prime, we are not going to take any step to either to the left or right. You just 6 steps up also. So from here, 1, 2, 3, 4, 5, 6. So this will be my C prime. Then finally, minus 3, 6. That's 3 steps to the left, 6 steps up. 1, 2, 3. 3 steps to the left, 6 steps up. 1, 2, 3, 4, 5, 6. Guys, that's all. You can see the beauty of transformation, guys. So especially when the reference point is not 0, 0. So we are true, guys. I'm just joining the coordinate. I want to use broken line this time around. So join A prime to D prime. D prime to C prime, C prime to B prime, and finally B prime to A prime. And if you look at this, is it true that this image, let me target I1, is it 3 times as big as the original object? So I1. Yes, if you look at the dimension here from D to C, it's just a square box. D to C here is 3 square boxes. Okay, from C to B is a square box, is 3 here. This is 2, this is 1, 2, 3, 4, 5, 6, so it is 3 times. I'm not going to work on center of enlargement here. It's also enlargement point is given already. So, but let me just quickly call your attention to this, so I don't need to do that again. If they ask you, if the question is giving object and image, and you ask that what is the type of transformation here, you want to determine this transformation, you just join. Guys, don't let me do that here. Let's just solve that problem. So let me wipe the board now. Let's just go ahead and do that. So let's go ahead to the next question. Let me import the question. So let's just solve one more problem on the enlargement. I just want you to appreciate enlargement question. Let's go ahead with this. Okay, now if you look at this question says that describe fully the single transformation that map A onto shape B. Definitely, you know this is enlargement, because you see that the B is bigger, so it's enlargement. So let's just start. So you have to give 3 information here. The first information is that we know the type of transformation. So the transformation is enlargement. 1. So you need 2 more information, because if it's enlargement, then you should be able to tell us what the enlargement point is, or the center of enlargement, if you don't mind, or the reference point. Then finally, then you give us the scale factor. So 2, let's determine the enlargement point. So to determine the enlargement point, you have to go ahead and label. So this is A, this is B. Guys, you can use any letter. I just choose A, B, C, D. This is D, and this is E. Then you label the corresponding coordinates in the image. So and this is D, then this will be D prime. This is more of negative stuff. You can see that this thing is inverse. Okay, so if this is E, if you look at this one is down, are you sure will this one be E, or E will be here? So guys, you need to know this is it's going to be a negative stuff. So definitely I'm sure that if this is A here, then this is A here. A, you know, it goes like this, A B like this, A B. So and when you turn it down, sorry about that, let me just where is the, let me just undo that. So let's clarify something. If you turn this, you know, this one, if it turns upside down like this, so this A, we move to this side, because if we turn it here, if we turn this thing, so this one we move up, this one will be, this will go to this side, this will come to this side. So that's why this is A, so that you understand my label, because it's upside down. So if you turn this thing upside down, this one we move here, and just invert it like that, and this one we move here. Am I correct? We are moving it like this. So it depends. If you just turn this thing upside down like that, A will come up here, then D will come up here. So this cannot be A. So there is no way you can do it that this will be A. So don't forget that. So I just purposely so I can't make such kind of mistake. So if you turn it like that, so this will be A. So this will be A prime. So this will be B prime. So I think I can just continue it like that, because I know the label already. So you move from A to B, then to C. So this should be C, because B and C are on the same line. Okay, and then this will be D prime, because you move A B C D, then E prime. So this will be E prime. So it could be quite confusing. So it depends on the way you want to do it. So that's cool. I don't have any problem with that again. So now just join the respective coordinates. So D to D prime, C to C prime. Okay, so I'm correct. E to E prime, B to B prime, A to A prime. So something is wrong there. So I know I made a mistake. So guys, so that turning is not correct, guys. So that's a good one. So my label is cool. So because the way it's turned is not that you don't just turn it directly like that. I probably made that so that you see something. Okay, so the label is correct now because it's not just directly. So it's not just that you turn this thing like that. So it's like you turn it as in such that this A is here. So A is not directly here. So this A here now, so it's cool. So that's a good one. So this time around, let me just use laser. So this is A prime. So we need to be fast now. A prime. So I can continue the label like that. So B prime. Then just use the rule and your initiative because you know that C and B are together here. C and B are together. So definitely this will be C prime. And you have D and E together here based on my label. I don't know. I clean this one. This E. So A and E are together. So this will be E. So and there's this we can't no there couldn't we can't have any problem with D because this is just this is this point here. So this is D. So then go ahead and do what I'm trying to do before now. So join the corresponding stuff now, coordinates. So D to D prime, C to C prime, E to E prime, correct, B to B prime, so directly, yeah, then A to A prime. Super cool. Guys, so what do you observe? So the line or the line have common the focus intercept here. Everything intercept all the lines, the corresponding coordinates. When you join, the line intercept at this point. So and let me take my line and put this point. Let me use this arrow. So everything intercept here. This is the intersection point of intersection. This point here. So this point of intersection is the center of enlargement, or better if you want it, enlargement point. So so the enlargement point EP, enlargement point EP. Okay, I need to be fast, guys. EP because of time is so what coordinate is that? That is 2, 2. So enlargement point is 2, 2. Then finally you have to state the scale factor 3. So the scale factor, generally scale factor is always given by the dimension of the image divided by the dimension of the object. So di over do. So you should be able to identify your object and the image. So based on the question, say that describe fully the transformation that map A onto B. So A exists before B. So B is the image. So just take the dimension. So let's just work with A prime, B prime. So let's take that dimension part. So divided by the corresponding dimension will be AB. So just count the square boxes now. So for that, how many square boxes do we have here? 1, 2, 3, 4. So that is 4. Divided by how many square boxes do we have? 1, 2. So 2. So the scale factor is what? 2. So by implication, it means that B should be twice or is as big as A. 2 times. So that's the solution. Okay, guys, let's go to the final subtopic under transformation. That is rotation. So I can clear my page now. So let's take a look at rotation question. Image. So I will just solve one question in rotation, guys, because of our time. I have R2, R5, and guys, I want to solve the difficult one. Let me just go for R5, R2, R4. Guys, let's just go for R4. Let's see. I don't know what is in there. So wow, that's a good one. Okay, so this is a good one. This is not a bad deal. Okay, maybe I can solve one more. Let's see. Okay, so let's just go with it. This 90 degree, then I can solve one more clockwise. Okay, so I'm not going to waste much time now. I will not take much time explaining, but I'll try my best to make sure that you understand what I'm trying to do. Okay, now the question is rotate triangle ABC 90 degree clockwise about center 1 to. Thank God this is labeled already. So now don't forget, we already learned how to determine the coordinates from enlargement question. So but this one now, instead of using enlargement, I'll just say rotation point to A, rotation point to B, and rotation point to C. What am I writing, guys? This is rotation point. It look like arrow, so don't mind me. Okay, so let me just take the arrow because guys, you understand this, but I'll also explain. I will explain again from enlargement point question. Okay, you can just go over the video again. Now this A here is not 2 comma minus 3. it can only be 2 comma minus 3 if the reference point is 0, because from 0 to A, that is 2 steps to the right and 2 steps down. That's when this coordinate will be correct. But when your reference point is not 0 0, then your conventional, your knowledge of coordinate system is not cannot work here. So you have to work with the reference point. So let me just go ahead and identify this one too first. So the rotation point now, reference point, guys, 1 2, that is 1x and 2y. So from this point, so I will be counting from this point now. So this is my rotation, this is my RP, from RP. So let me just use laser. So RP. So it's from that point. So RP. So from RP to A, from RP to B, from RP to C. So that's it now. Okay, so let me just go ahead with my soft pen. So I want to get coordinate of A. So I want to get the coordinate for B. And finally the coordinate for C. So let's the coordinate for A, from RP to A. So you can't just move down, guys. Don't forget, you have to move left or right before you can move up or down. So then 1 step to the right, then how many steps down? 1 2 3 4 5. So this is 1 minus 5, because down is minus. 1 minus 5. So from this point to B now, so 1 2 1 2 3, that is 2 3 minus 3, because that 3 is down and the 2 is right, that is why it is positive. Okay, from rotation point to C also, rotation point to C, 1 2 3, then 1 2 3 4 5. So 3 minus 5, 3 minus 5. So we have a coordinate now. So what do we do with this now? So guys, unlike enlargement, that you just use your scale factor to multiply out. For rotation now, you have to learn this concept now. So let me just let me quickly show you this. I think I'm not going to waste my time with this. I will just work with 90 degree, and I will explain others, but I'm not going to put that one down because I'll solve one more question in order to establish your knowledge. Okay, now what do you observe here? This is Cartesian plane. Okay, like you have your x and y, x and y. It's x and y. It's quite funny. So you are this is your Cartesian plane. Okay, your coordinate like you have your Cartesian plane. Don't forget your x and y. Okay, so don't forget that this is y, positive, and below y this is 0 here. So below 0 you have negative y here. So this is your x coordinates, and to the left hand side you have minus x. Okay, so guys, generally the coordinate is always represented by x comma y. There's nothing like minus x minus y. We always have x comma y. So that is the original coordinate. So this is the object. This is like the object now. So like you have here now, this one 1 minus 5. This is x comma y. That's the general form. So now we want to see the effects of rotation now. So let's now get the formula now. So I want to derive formulas for 90 degree, for 90 degree, for 180 degree, for 270, but I'm not going to waste my time with all the remaining one. I'll just explain 90 degree, then I'll go ahead and I'll give you into 270 etc, but I'll just work with 90 degree because of our time. I want to solve one more question. Okay, so for 90 degree now, so 90 degrees should be the coordinate, the original coordinate, the conventional coordinate is x comma y. So but after translation, after rotation, so what will be the effect on the coordinates? So that's what I want to derive. So you can derive for the remaining one. I will tell you what to do. So now this is x here. So always start from x before you go to y. This is starting point x. So 90 degree clockwise. This is clockwise. Clockwise move like this. This is how clocks move. So this is clockwise, c-wise. But if it were to be anti-clockwise, it's against it like this. It's move like that. This is AC wise. So the reference point now is x. So x clockwise 90 degree, and this is 90. This is x. I'm starting from x. So x 90 degree. This is x 90 degree. So x will change to y. But if it were to be 180, x will change to minus x. If it were to be 270, x will change to y. And if it's 360, x will go back to x. So you understand the concept now. But I'm working with 90-degree clockwise. So 90-degree clockwise, x, this is x, x change to y, to minus y rather. So 90-degree, x change to minus y, 180, x change to minus x, 270, x change to y. So the coordinate is this x will change to what? Minus x. So minus x, comma. Then I want to see what y will change to. So x change to this. So let's see what y will change to. Because generally we normally have x comma y. So this is y here. So starting from y. So 90-degree. So y change to what? X. So y change to x. Sorry again. X change to minus y, but I wrote x here. Don't mind me. So x change to minus y. See, x change to minus y. So don't mind me. X change to minus y here. Sorry about that. So x change to minus y. So 90-degree, x change to minus y, and y change to x. So that's the formula I have now. So I want to work with this formula. I need to interpret it. Minus y, comma x. So let's see the effect of this on this coordinate. So I have 1 minus 5. So my interpretation of this is that because you normally have x comma y. So y comma x means that you should swap the coordinate first. So swap each coordinate. So I want to get a prime, b prime, and c prime. So step 1, because this formula there are 2 steps there. Swap the coordinate, then apply the negative. So to swap now, so you have 1 minus 5. So mean that that will change to minus 5 and 1. Just swap it. So for example, 2 minus 3 will change to minus 3, 2. Just swap, just something like that. Then finally, 3 minus 5 will just change to minus 5, 3. So the last one come first and the first come last, something like that. So just swap. So write minus 5 first before 3, write minus 3 first before 2, write minus 5 first before 1. That's 1. So that's the, I'm trying to interpret this. Then finally, then the negative.
Wake the streets up.